A pleasant good morning to all of you. In this lecture, we will see the definition of differentiation. So, in order to understand the definition, we will consider a curve y equals to fx. Then we will plot 2 points, point Q. Now we mark x comma 0 on x-axis. So coordinates of Q will be x comma f of x. Now we mark x plus h comma 0 on x-axis. So the coordinates of P will become x plus h comma f of x plus h. Now we need to find out the slope of line segment PQ. We can also call line segment PQ as chord PQ because it is intersecting the curve at two different points. So in order to find the slope, we need to find out tan theta, and theta is nothing but the angle which the line segment is making through the positive x-axis. So let's find out the sides of right angle triangle so that we can find out theta, and ultimately we will find out the slope, that is tan theta. So the length are h and f of x plus h minus fx. Now see here, the tan theta will be perpendicular upon base, so we will get the slope of line segment PQ or chord PQ. In a right angle triangle QRP, we have tan theta as PR upon QP. The length of PR is f of x plus h minus f of x, and QR is h. This is change in value of fx upon change in value of x. Now notice one thing, as the point P approaches to Q in curve y equals to fx, what will happen? P will become closer and closer to point Q. Then the length of chord PQ will almost become 0 at certain point when the P is very close to Q. In this process, the length h will also approach to 0. So two things will happen. The length of chord PQ will become almost 0, and the length of h will also approach to 0. Now we will write it down as P tends to Q, S tends to 0, and theta approaches phi. So the chord PQ becomes the tangent at point Q. Now understand this. As P is approaching towards Q, theta is also decreasing. At certain point, when P is very close to Q, thus this theta will become phi. So when we will apply the limit s tends to 0, so we can write tan theta as tan phi. So let's write it down. When we apply limit, we are applying limit on the above equation. So we are getting limit s tends to 0 tan theta, which will ultimately become tan phi, and limit s tends to 0 f of x plus h minus fx upon h. So this tan theta becomes tan phi, and we are writing it down as it is. This is nothing but the derivative of fx with respect to x. This is our first principle of derivative. Now some notation which we have used are df upon dx. This is a small change in the value of function when there is a small change in the value of x. So here we are considering a small change, or we can say instantaneous change, while del f upon del x is average change in the value of a function fx with respect to change in the value of x. So here we are considering average change. So we can say the derivative of any function. The derivative of any function at any point give us the slope of tangent at that point. ठीक है, तो डेरिवेटिव क्या बताता है? डेरिवेटिव हमें ये बताता है कि स्लोप क्या है, टेंजेंट का स्लोप क्या है उस पॉइंट पे.